What follows is a demonstration of the capability of the DB5i MV 4160 volt drive to take a connected motor and synchronize it to the power line, and then desynchronize it and replace the motor onto VFD control. The tests were run in April of 2010 in a factory setting. The drive used in the test is a 4160 volt input and output drive, 2500 horsepower, with built-in capability to synchronize and desynchronize its load from the power line. This simple one-line diagram illustrates the system under test. The converter inverter represents the DB drive. Internal to its control is the ability to monitor output voltage and input voltage and compare the two so that the motor can be transitioned to the utility. Contactor M2 connects the motor to the drive. Contactor M3 will connect the motor to the utility in bypass operation. Relay 25 verifies that conditions are correct for the transition. The drive control is programmed to do this transition, and Relay 25 is a verification tool. In the test setup, this single contactor section with output contactor and bypass contactor is used to provide the synchronizing power switching function. This detailed shot of the DB5i control shows the microprocessor and the associated relays included to perform the drive control and synchronizing functions. A dedicated potential transformer measures the output voltage of the drive and sends it back to the synchronous check relay and the microprocessor for the synchronizing process. The synchronous check relay itself is mounted in the drive and is connected both to the input voltage and to the output voltage to verify the synchronization process. We're going to demonstrate synchronized to line. What we see on the screen right now is the utility power, and we have just started the drive. He's going to give it a 50% reference and run the drive. We're going to watch the motor come on, start to accelerate from 0, sit for a while at 50% speed. It's at 2 levels. Accelerating, brakes into 3 level. After it stabilizes, we'll synchronize. Go for it. Now we're going to synchronize. We're going straight up to synchronize. Okay. There we go. That's increasing. You're at 5 level operation now. Approaching line frequency. Roughly 90-second ramp this drive is. Now we're at 5 levels. This detailed sync check relay is concurrent with the synchronizing process within the drive. Note the indication of the relay at synchronizing time. Synchronize. Okay. Now desynchronize. You don't have to shut off. Go for it. Now we're going to desynchronize. And wait for the fans to come up.
Output contactor closed. Frequency match. We are now on the VFD, taking it back down to a lower reference, probably like 50%. Down to preset speed, whatever the system desires. Motor slowing down to the preset. There we go. There we are. Now it's whatever speed it is in. That's good. All done.
The DB5i drive comes in several other configurations of synchronizing motors to the line. In this one-line configuration, 2 additional contactors for input and output are incorporated into the system, allowing motor 1 and motor 2 to be controlled by the drive or synchronized to the line. This shares drive resources. This concept can be extended as shown here for 6 motors and 2 drives. Each of the drives is redundant in that either drive can control any of the 6 motors one at a time and synchronize any of them to the power system as required by the process. In this case, the process is used on board a operating oil platform. The switchgear for the 6-motor 2-drive system is shown here. Each of the switchgear modules is coordinated by a built-in PLC which talks to the drive and coordinates the process in response to the platform requests. Thank you for your attention during this demonstration.